Hello, folks. This is a pretty simple example, lesson of a few simple examples from the Harrington book, and we will just have some screenshots and a few comments. We should get through this pretty quickly. This is your instructor, Jeffrey Fox, in Machine Learning and Cloud Services, Part 1, K-means clustering, April 2019. And then we first look at T-shirts. Just what we wanted. And we're trying to design how many sizes we want. And we try to do that by clustering weight versus height of clients. And we can look at various many clusters. And there is a Python code which works up to plotting 5 clusters. And here we have, this is Matplotlib, of course. And here we have 2 clusters, 2 t-shirt sizes. And here's the first cluster, and here's the second cluster. And these are the centers which we should be aiming at. Here is height in inches. Here is weight in milligrams, or what have you, maybe not milligrams. And here we have 3 clusters. We managed to slip in a blue cluster in the middle of the 2 other clusters, which look actually pretty similar. So we can have 3 shirt sizes, a large, medium, small, or so on. So that's actually not so many. You usually have more sizes than that. And here's a second example coming from dating rating with their free feature, which you rate people on 1,000 points. And the categories have been assigned by the users to the points. And here is the specification of where you get all this stuff from. It's online. And we compare labeling of points from people with new clustering, which uses my favorite advanced method using so-called deterministic annealing. But I don't think for this problem it matters what you use because the clusters aren't very clean. And the new clustering has the centers marked. The old clustering are just labeled by color of points. And then we have side-by-side pictures of the user clustering and the machine clustering, and the 3D data is projected in different ways to 2D. There we are. Here we have the original user labels over here. Here we have the k-means. Well, in this projection, they don't look so similar, do they? In fact, they look totally different because this one is done in stripes across, in vertical stripes, sorry, horizontal stripes, and this one is done actually just in blobs. So well, I mean, that's just inevitable. There's no clean structure in this problem. So when you're doing dating, it says with these features, you're going to just be able to find dates which are similar to other dates, not ones that are dramatically clearly associated to your tastes. Here we are. This is the same data but just rotated. Now the original labels are pretty clean, and the machine plotting. By the way, notice that the machine-generated data clustering has centers, so you can see the the centers of the labels. Another one, and that's that. Now we can do the same data. We can do more clusters. And we have 3 clusters, which is what we had before, or 28. 28 should have been 30, but in these fancy clustering programs, sometimes you start with 30, but then some of them disappear because during the iteration, the number of points in the clusters goes to 0. I noted that when I discussed the Wikipedia example. We could have chosen some initial conditions where there were 0 points in the clustering. And the key point is, which we'll keep on emphasizing, clustering always takes your big space and divides it into subspaces. And that is often all you need. You don't actually need to have clean clusters. And here we have, here we have our machine clustering into 3, and we have these 3 blobs. That's what we saw before. And here is a rotation, still 3 blobs, but differently located. Here we have 28 clusters. So here are the centers. You can see they're still blobs. but these blobs are compact and much smaller in size than the previous blobs. That's what you expect. If you divide the world into 28 parts, those parts will be smaller than if you divide into 3 parts. And here we have another view of the 28 cluster solution, showing essentially the same information. So